Welcome to a new chemistry lesson, where we will be talking about chemical reactions. In this lesson, we'll take a look at all the main reactions in inorganic chemistry. For this lesson, you will need to know a few following things: how to make chemical formulas, which compounds are acids, hydroxides, oxides, and salts, and lastly, how to balance the reactions. I covered all these topics in my previous lessons, so you can check it out, and I really appreciate that. And now, let's dive into the lecture. In the first example, sodium hydroxide reacts with aluminum chloride. So the first thing you want to do is to decide which reaction type is this. Is it a synthesis, decomposition, single displacement, or double displacement reaction? Here is a brief example of each reaction. Usually, in a synthesis reaction, two elements form one compound. In a decomposition reaction, one compound decomposes and forms two or more products. In a single displacement reaction, reactants are always a compound and an element. And in a double displacement reactions, we have two compounds. So if we look back at our reaction, we can see that two compounds are present. So we know it's a double displacement reaction. In these reactions, both reactants must be soluble in water, unless one of the reactants is an acid. It's called the reactance rule. Sodium hydroxide is a salt, and the same goes for aluminum chloride. So now we can use a solubility table to check each reactant solubility in water. We intersect each cation and anion in the table, and we can see that both salts are soluble in water. Now we can write our products. You must remember that ions interchanges places with each other. Sodium attaches to chloride ions and aluminum connects to hydroxide. Always connect positive ions with negative ions. Lastly, swap the charges with subscripts to get new chemical formulas. In double displacement reactions, one of your products must always be a precipitate, gas or water. If there is no precipitate, gas or water, reaction doesn't occur. In this case, we can cross out gas and water, and if we look at the solubility table, we will see that sodium chloride is soluble and aluminum hydroxide is not. So that means that this reaction occurs, and all that's left is to balance the reaction. In the next example, we have a reaction between a compound and an element, which means it's a single displacement reaction. In a single displacement reaction, an element must always be more active than the metal in the salt. To check that, you must use a metal activity series. The most active metal in the series is the one at the top, and the most passive metal is at the bottom. So in this case, it's potassium and gold. Now, let's find the metals in the reaction. As we can see, zinc is more active than copper, so the reaction will take place. All that's left to do is to change zinc with copper and swap the charges with subscripts. In this case, we don't need to balance the reaction out. In our third example, we have another double displacement reaction, because two compounds are present. So let's apply the reactance rule. Silver nitrate is soluble, however, calcium carbonate is not, and because of that, reaction doesn't occur. Don't forget that both reactants in these reactions must be soluble in water. Next, we have a decomposition reaction, because we can see only one reactant. In these reactions, reactant must always be insoluble in water. So let's look at the solubility table to find out. As we can see, magnesium hydroxide is insoluble, so we can proceed with the reaction. In these reactions, a metal oxide and water forms. If we have a decomposition reaction where carbonate or sulfide is present, we always get a metal oxide and CO2 or SO2 gases. Do not forget to always check if you need to balance the reaction. In the fifth example, we have a synthesis reaction, because only two elements are present. In synthesis reactions, you must always connect both elements, swap the charges with subscripts, and balance it out. Synthesis reactions are the simplest reactions of all. No rules, nothing. Just connect both elements to get the product. In the sixth example, we have another decomposition reaction. So like the last time, we check if our compound is soluble. In this case, it is, so the reaction doesn't occur. We have a few more reactions to cover. This time, we have a double displacement reaction between potassium carbonate and sulfuric acid. Because we have an acid present, reactants rule doesn't apply, and we can proceed with the reaction. Like always, two products are formed, potassium sulfate and carbonic acid. The latter is an unstable product, so we cross it out and instead we write CO2 plus H2O. There are three unstable products that you must always be aware of: H2CO3, H2SO3, and H4OH. Each of them always produces water and gas. As we can see in this reaction, not only gas, but water formed as well. A quick reminder, in double displacement reactions, a product must always contain one of three following compounds: solid, gas, or water. In our last reaction, we have an element plus compound, so we can easily say that this is a single displacement reaction. A single metal must always be more active than the metal in the salt. In this case, silver is less active than magnesium, so the reaction doesn't occur. And that is how you write chemical reactions. If you know the reaction type and the rules, it's not so difficult to do it. Thank you for watching this video. I hope I helped you to grasp the chemical reactions better. And like always, I will leave some chemical reactions for you to practice with. If you have any questions, please write in the comments below. Or maybe you want me to cover some other topics. Please do not hesitate to ask. Please have a good one, and I hope to see you again. Here are the reactions, and in 10 seconds, you will see the answers. So please stop the video now.